Hey everybody, I hope you're having a great day. So today we're going to move on to section 10.2, where we're going to be doing tests for independence. This is going to be different from 10.1 where we did our goodness of fit, where we had a distribution, an observed distribution, and we did a test to see if it matched the expected distribution or not. So today is going to focus on independence, and we got to think about this in probability terms. Okay, if we have two events, how do we determine if they are independent or dependent? Well, independent would mean the likelihood of one does not impact the likelihood of another. So think about if I roll a die and I flip a coin. Does rolling on a 3 on the die affect the probability of me flipping a heads on the coin? No, it doesn't. Those are two independent events. Okay? Dependent is where the probability of one impacts the probability of the other. Think about if we have a deck of cards, okay, and what's the probability of drawing a king and then another king? Well, if we don't replace that first card, what we get on the first card is going to make an impact on the likelihood of getting that king on the second card, and those would be dependent. So here's the situation that we're going to look at first. Okay, we have 4 different occupations: clergy, an MD, a lawyer. Well, actually only 3, never mind. That last one's column total. Hey, we have 3 occupations. Now, we're going to use some information off the Myers-Briggs personality test, and I'm not sure if you're familiar with that at all. There's kind of 4 different categories it puts people into, kind of makes different quadrants, and one of the axes is for extroverted versus introverted people. So we have a random sample of 406 people from these different occupations. E is going to be extroverted and I is going to be introverted. So we gave them the Myers-Briggs test, and of the clergy, okay, 62 were extroverts, 45 were introverts. For the MDs, 68 were extroverts, 94 were introverts. For the lawyers, 56 were extroverts, 81 were introverts. So let's think about this in terms of independence versus dependence. Are the personality types independent of the occupation? Okay, by that I'm asking, does the personality type, is that dictated, is that impacted at all by their occupation? Or does occupation and personality type, are they related? Okay, does your occupation kind of dictate it a little bit by your personality type? Okay, so that's what we want to test for in this. Now, how are we going to do that? Well, let me give you the setup on this. Okay, a lot of information here on this next page. Okay, this is going to be a chi-squared independence test, so we're still using our chi-squared, and take a look. That formula should look familiar to you from our last section with our goodness of fit. Conditions here before we get too far. Observed frequencies have to be from a random sample. Expected frequency for each, not reach, let's fix that. For each cell must be at least 5. So if you recall with goodness of fit, we calculated that expected frequency. How are we going to do that now when we have the different variables, different categories? Well, we're going to consider each of these to be a cell. So I see 6 cells here. And now, that's what I meant here when I said the cell had to have an expected frequency of at least 5. You find the expected frequency by taking the total in that row times the total in that column and dividing it by our sample size. So if we look back at this, the row total is 107. There's 107 clergy that were in this random sample. For the extroverts, the column total there is 186. There's 186 extroverts in this random sample. So we're going to find the product of those two, 107 times 186, and we're going to divide that by the total sample size of 406. So let's do that quickly here. Get my pen out and working. So we're going to take 107, that's this one, times 186, and we are going to divide that by our total, 406. And let's see what that is. 107 times 186 divided by 406. 49.02. So let me squeeze that in there. 49.02. That's what we expected. Notice we had 62 that we observed. Our expected was only 49. So we see that this was larger than what we expected by about 13 people. So that's how we get the expected value. Our hypotheses. Excuse me while I answer the phone. All right, so our null hypothesis is that the variables are independent. So that's what we're assuming. We're assuming independence between the two, and we're going to test on that. Okay? Our alternative is that the variables are dependent, that one category variable makes an impact on the other. Okay? So we test that. We test the null hypothesis just like before. We will either reject the null hypothesis, which we then make the statement there is enough evidence to support that they are dependent, or we fail to reject the null hypothesis and we make the statement there is enough evidence to say the variables are independent. Now, we are dealing with a chi-squared distribution. Our degrees of freedom, what we do is we take the number of rows and take one less than that. We're used to that -1 with degrees of freedom. So we take the number of rows -1 times the number of columns -1 to get our degrees of freedom. So, let's use a chi-squared test to determine if the listed occupations and personalities really are independent at a 5% level of significance. So we need to find the expected frequencies for each. We said this one is 49.02. Let's go to this one here. Let's see here, row total, 107. Column total, 220. Divided by total sample size, 406. $57.98. All right, now we'll go to the next one. We're going to take row total, column total, 162 times 186, over the total sample size, 406. $74.22. Okay, you get the idea. What I'm going to do now is I'm going to pause the video. I'm going to calculate these last three, and then we'll get back together. All right, I've finished that last three. Now, one thing to remind yourself, when we add up all the expected frequencies, we better get a total of 406. We might not be perfect because of rounding, but if you want to double check that you did that correctly, the sum of those should be 406. All right, so let's complete our test. So, let's check conditions. Observed frequencies from a random sample. Right there. All right, so conditions. Random sample. Got it. Second condition, expected frequency for each cell must be at least 5. Well, let's take a look at each cell. We certainly have that. E is greater than or equal to 5. Check. All right, hypotheses. Null hypothesis. Personality, type, and occupation are independent. Alternative hypothesis, personality type, and occupation are dependent. Now, just taking a look at this statement to determine if the listed occupations and personalities are independent. So technically, this one up here is our claim. All right. So now what? Well, remember that we are doing a chi-squared test here. Okay? We need to find this. Now, to do that, okay, just like with our goodness of fit, we're going to use our calculators. Now, because we have different occupations, we have different personality types, I got to find a way to stay organized with each cell, because each cell is going to be a spot in our list. So I'm going to just write out my cells this way here. We're going to call this cell 1, 2, 3, 4, 5, and 6. So I should have my calculator here somewhere. There it is, 62, 60, there they are. Okay. So I've just put those 6 cells into my calculator in list 1. Now what I need to do, okay, is I need to put the expected frequencies into list 2. So our first one is 49.02. So I'm going to go here, 49.02, and I'm going to make sure that's matched up with the right cell. So I'm going to pause my video and do the rest of those. All right, so I have them all in there now. So now it's time to get that chi-squared. So, just like before, observed minus expected squared over expected. So we're going to take, oops, I got to get up there onto that. Here we go. So parenthesis, observed, list 1 minus expected, list 2, parenthesis, squared, divided by the expected, list 2, enter, there we go. Okay. That's what we're looking for. Now we need to find the sum of those, so we're going to go stat, calculate, one variable statistic. I'm still working in list 3, and there we go. Our sum is 8.65 or 8.648. All right, so we're going to use our degrees of freedom here. Now, how do we do that? Number of rows minus 1 times number of columns minus 1. How many rows do we have? 1, 2, 3. So 3 minus 1. Columns is 2 times 2 minus 1. That's 2 times 1, which is just 2 degrees of freedom here. So, these are non-symmetrical chi-squared. We're using a level of significance of 0.05. So I'm looking in my book right now. 0.05, 2 degrees of freedom. That's just 5.991. Sets that rejection region. Our chi-squared is in there. So we reject the null hypothesis. There is enough evidence to support that personality type and occupation are, now we rejected the null hypothesis, which said they're independent, so now we're saying they are dependent. And, you know, just looking at this, notice how much different our observed frequencies are than our expected. See, the clergy, extroverts was more than we expected, introverts were less. MDs, less extroverted, more introverted than we expected. Lawyers, less extroverted, more introverted than we expected. So this is not a surprising result to me as I look at our table, and we say that yes, they are dependent here, that our personality types are affecting the likelihood of the occupation. So, pretty neat test there. Tune in for the next video. I'll look at another example with you. Thanks, guys.